Okay, continuing with our notes for section 12.1. We can use the distance formula, or we can simply extend the idea of the equation of a circle to find the equation of a sphere. So if I think about it as using the distance formula, if I have a center of the sphere at the point, let's call them x naught, y naught, z naught, and I want a sphere of radius a, so that's a radius of a in every direction. Any point x, y, z that is on the surface of this sphere, any point x, y, z on the surface of the sphere will have the distance of a to the middle of the sphere. So the distance formula would be take the square root of x minus x naught squared plus y minus y naught squared plus z minus z naught squared would equal a. So if I square everything, this equals a squared. So it's really simply extending the idea of a circle, but now we have that third component. Okay. So for example, let's say I gave you a sphere, and how would you recognize, first of all, this was a sphere? As soon as you see an x squared, a y squared, and a z squared, and those are your three highest exponents for the x, y, and z, maybe some lower ones, but nothing higher, you know that we're dealing with a sphere. So what we have to do is we have to turn this, which is called, this is not in standard form yet. We have to take this equation, we have to turn into standard form, which is this one right here. So you have to remember how to complete the square. So let's walk through that. We got x squared plus y squared plus z squared plus 3x minus 4z plus 1 equals 0. So first of all, put all the x's together, x squared plus 3x, all the y's, we just have y squared. And all the z's, z squared minus 4z, bring in any constants to the other side, so subtract 1 from both sides equals minus 1. Then we complete the square. So remember the coefficient of x squared here is 1, so to complete the square, we just take half of this coefficient of x, which is 3 halves, we square that and add it to, so 3 halves squared would be 9/4. So same thing over here with z squared. We take half of the coefficient of negative 4, which is negative 2. We square that and we get 4, so we add that. Now, we added 9/4 and we added 4 to this side of the equation. So on the other side of the equal sign, we also have to add 9/4 and 4 so we don't change the problem. By completing the square, though, it gave us a perfect square, which is always, since the coefficient of x squared is 1, it's always x plus whatever we took half of, so here 3 halves, and then that quantity is squared. If you FOIL that, you'll see how you get back to that. Y squared, of course, the same as y minus 0 squared, and then this is now z minus 2 squared, right? We took half of negative 4 to get negative 2, so it's z plus or minus 2, or z minus 2, quantity squared. Equals on this side, you bring these numbers together, you get 21/4. So our center is at negative 3 halves, because it's x minus a minus 3 halves. Y minus 0, 0. Z minus 2, 2. Center is at minus 3 halves, 0, 2. The radius is the square root of 21/4, or square root of 21/2.